So to derive the ideal gas equation, we're simply going to use all the three laws that we know. So the first one is simply going to be Boyle's law. So we know to say the volume is simply proportional to the reciprocal of pressure. So this is Boyle's law. So we know this. And we also know, according to Charles' law, that the volume is also proportional to the temperature. That's what we have. So this is Charles' law. Now, you don't have to stipulate the names whenever you are proving this to answer your question A. You just have to state this. Then we know Avogadro's law. It simply states that the volume is also going to be proportional to the number of moles. This is Avogadro's law. This is what we know. And we can join all these three equations since we are having the fact that we can relate volume with all the three expressions this side. It simply implies that volume is simply proportional to joining all these three things here. This is simply going to be N, then we have T over P, right? This is what we are having, and this can be simplified to be PV is related to number of moles times T, and these are supposed to be connected via a certain constant. So let's let R be a constant. So you show this constant relating the two sides. Yeah, so we know how things are related. If you say y and x are connected with y and x are connected by a constant k, it's the same thing here. We're just going to say PV is simply connected via a constant r. Then we have nt this side. This implies that the PV is equal to nRT. This is where the ideal gas equation comes from, hence shown. So you write hence shown. Yeah, no need of putting this part here. So this is how you were supposed to derive the whole equation. Let me give you an alternative way to come up with it again. So another way that we can do this, which is almost similar though, we can start with the same Boyle's law that we had. We know to say, according to Boyle's, the pressure is simply proportional to the reciprocal of 1 over this, meaning we can just say pressure times volume is simply equal to some constant. Let's call it K1. That's going to be your first equation. You can have that. And Charles' law says volume is proportional to temperature, right? So according to, we also come up with this. This is proportional to temperature. So if they're proportional to each other, meaning there's something connecting them, and we can just say V is equal to, let's call it K2, let's call it this. This is the connection between the two. And we have the Avogadro's constant, expression, the relation that we have, the Avogadro's law, which says the volume is also related to the number of moles, meaning we can create V to be an expression that has another constant related to the number of moles. This is the third equation. Now, we notice that there's a constant between all these relations, so we are going to combine them. We'll start by combining the first one and the second one. If we do combine them, we're just saying where there is the expression of, we say this is going to be, so we're going to take a case where the constant K1 is a little bit less as compared to K2. We're just going to take that assumption, and we're going to take PV, the first part here, to be equal to the last part this side, because we are saying it's like they're conjoined. So let me just say this. It's like we're saying K1, then we're saying where there's K1, we'll just put this to be, I don't know if you'll be okay with this. Let me decide to put this. Maybe this will be okay for now. So joining them, we already have V this side. So V, already we are saying V is equal to K2 times T. Then we also know to say P, V is equal to K1. So this is just like us joining them. Yeah, so hope this will make sense. Then we have to relate what we've gotten by the third expression. So to join, combining together with the third expression, we're simply going to get PV is equal to, we can write like this, K1, K2, and K3. Then we're having T. It just so happens to be that R, which is 8.3145, was the K1, the K2, and the K3. So that's where the PV is equal to nRT comes from. This here is the ideal gas equation. So this is what you can use. Then the second part of the question, they're asking for use the derived equation to calculate the value of the gas constant R. So there are no other conditions that were stated, so we know to say PV is equal to nRT. We're looking for R, so we're simply going to use something like this, meaning R is equal to PV, then divided by NT. So, and to do that, we're going to take a case where we're looking at the conditions. So this is part B. So we say at STP, let's take this best case, standard temperature and pressure. We know the temperature has to be a 273.15, and the pressure at STP is simply going to be 101.325. This is pascals. Then the volume, we're just saying the volume is simply going to be 22.414 times 10 to the power negative 3. This is what we're getting. That's for every single mole, cubic meters per mole. So we're just going to replace everything. So we know R is, number of moles is simply 1. So this is just 1 in case you're wondering. Then here we know this is PV. Then we have NT. So we're just saying the pressure. So we can go back to your document, check the data given. So let's see if they gave us the constants. Okay, here they didn't give us on the cover page, but at the end they gave us here. Yeah, so we're saying at STP they should have given us the conditions. Regardless, we know to say we are having this as your 1 atm is the same as this at standard temperature and pressure. So that's what we're simply going to use. If we do the replacement, the pressure is 101.325, multiply the volume 22.4 liters. That's the volume of per mole for every single mole, right? Then this is the number of moles, that's just 1 mole. Then we have the temperature 273. So this is how you're going to get your answer as 8.3145. We need to put the units, that's joules per mole per kelvins. So this is how we were supposed to do question number 7 from the Premed test that you had. So this is what was needed. So for the full video of the whole paper, you can just WhatsApp me on this number 0978 73 90 then 38.